Okay, and this video coincides with lesson 8.4 in your textbooks. Okay, so we use scale drawings to show something that's too big or possibly too small for an actual size drawing. All right? When are we going to use this? That's the age-old question. Well, scale drawings is something that people use all the time. If you were to draw a picture of your house, you wouldn't make it an actual size drawing. It'd be a pretty big drawing, or it would take up an awful lot of paper. You'd instead make your drawing to scale. I think I told you guys this. I live in the woods, and we actually built our own home. My father-in-law is a contractor. My wife's she's got a couple cousins who are framers. Another cousin who's a plumber. I've got a good buddy who's an electrician. So we owe a lot of favors. I was in charge of pizza, bagels, and donuts, and did a pretty good job. But anyway, before we started building the house, we sat down with an architect, and we told him what we wanted, and he came back to us with a set of plans, and that's how the guys were able to build the house, off of that scale drawing. Okay. Maps. Maps are another example of scale drawings. As a kid, we used to take road trips, and so a couple days before we'd go away, Dad would go down to the AAA, and he'd sit down with somebody from AAA, and they'd pull out a map and a highlighter, and they'd actually highlight, the best route for us to take for our trip. So obviously this was before, people had GPSs in their cars and on their phones. Okay, so every trip it was the same way. Typically Dad would drive and Mom would be in charge of the map, and every single time we'd get lost, or we'd miss an exit, or whatever the case was, and Dad'd be upset because we're off schedule now, and which is funny because we're on vacation, and the whole point of being on vacation is not having a schedule. But anyway, let's get to some math. Okay, so the scale on a map is the ratio of the distance on the map to the actual distance. Okay, so by knowing the scale, we can find whatever it is that we're looking for by writing and solving proportions. So let's look at a map. Okay, so here's a map of my house and Yelner's house, and some god-awful tree here. But anyway, you can see that the map scale is 1 inch to 10 miles, okay? Where 1 inch is the map distance and 10 miles is the actual distance, okay? So how I like to set up my proportions, so here's our proportion, right? 1, 2, 3, 4, okay? Is I like to let the scale be half the proportion. So I'll usually do it this way, where I'll go 1 inch on top, and then 10 miles on the bottom, okay? So what you have to understand is that, this is our map distance, and this is our actual distance, okay? So if we set up the left side like that, we have to set up the right side like that, where on top we're going to have our map distance, and then on the bottom we're going to have our actual distance, okay? So let's pretend that the distance from my house to Yelner's house is 3 inches on the map, okay? We want to find out what the actual distance is. I know you guys all know the answer real quick. Is 30 miles, but that's that's not the point. The point is being able to set up the proportion. Okay, that's truly the hard part. Okay, so that 3 inches is going to go on top, and the reason it's going to go on top is because that's our map distance. And then obviously to get from 1 to 3, we're going to multiply times 3, and 10 times 3 is 30, so it's 30 miles from my home to Yelner's house. Okay, obviously we can go this way as well, right? Where we do our cross products. Okay, I want you to see that that this can be set up more than one way. So let's say we were to set it up this way, all right, where we did 1 inch to 10 miles. Okay, so again, this is your map distance, this is your actual distance, okay? So for this proportion, we have our map distance on the left side of the equation and our actual distance on the right side of the equation, okay? So now that 3 inches is going to go on the left side because that's our map distance, okay? And then we'd be solving for x. And I just want you to see that these two proportions wind up being the same thing, right? 1 times x equals 3 times 10, which is 30. 1 times x, and 10 times 3. Okay? So, again, the point is that you can set this up more than one way. You just have to be consistent with how you set it up. All right? So, let's do another example. All right? So, let's say we've got a scale of a 1/2 inch to 20 miles and a map distance of 5.5 inches, and we're looking for the actual distance. All right? So, again, I'm going to take my scale. That's going to be half my proportion. 1, 2, 3, 4. All right. So here's 1, 2, 3, and we're looking for the fourth thing, which in this case is the actual distance. All right. So I like to do it this way, where I go a 1/2 inch over 20 miles. Okay. All right. So again, my 1/2 inch is my map distance. The 20 miles is my actual distance. On this side, map distance on top, actual distance on the bottom. Since the 5.5 is the map distance, that's going to go on top, okay? And then we're solving for the actual distance, all right? So we're going to do 1/2 times x, which is a 1/2 x, and that equals, we're going to do 5.5 times 20. All right, so let's do that over here. 5.5 times 20. Now, if you wanted to, you could turn this into a decimal. You could do your distributive property where you do 5 times 20 is 100, and half of 20 is 10, and 100 plus 10 is 110. We can go improper fractions, right, where we make this 11 over 2 times 20 over 1. And we could simplify before we multiply, right, and this becomes 10, and this becomes 1, and then 11 times 10 is 110, and 1 times 1 is 1, and 110 over 1 is 110. Okay? So now our algebraic equation is a 1/2 times x equals 110. And then we solve like we would any other algebraic equation. We isolate our variable, right? And now we've got 110 divided by a 1/2. So 110 divided by a 1/2. And I know you guys all know how to divide fractions, right? Before we do our keep, change, flip it, right? We're going to make 110 improper, right? So we'll keep that 110 over 1. We're going to change the division to multiplication, and then we're going to flip a 1/2 and make that 2 over 1, okay? If you recall, 2 is the reciprocal or the multiplicative inverse of a 1/2, right? So now 110 times 2 is 220, and then 1 times 1 is 1, and 220 over 1 is 220, right? So if we have a map that has a scale of a 1/2 inch to 20 miles, and the map distance is 5.5 inches, well, then the actual distance is 220 miles. Okay. Some of you might see right away we could, if a 1/2 inch is 20 miles, then 1 inch is 40 miles, right? So if 1 inch is 40, 2 inches would be 80, and so on, right? Well, if we do 40 times 5, that's 200. Half of 40 is 20. 200 plus 20 is 220, and that's just, again, an example of that distributive property. All right, let's try one more. All right. Whoops. So let's say that we're going to do a room, right? Or in this case, our home. All right. And let's say the house measures it's 40 feet long, and it's 25 feet wide, and your scale is 1 inch to 4 feet. Okay. So here you're going to have to do two proportions. You're going to have to do one to find the length of the drawing, and then one to find the width of the drawing. Here you've got the actual distances, and now you're going to look for the drawing distances. Okay, so let's take our scale. That's a 1/2, that's 1 inch, pardon me, and 4 feet, right? So this is now the drawing. It's not a map this time. This is your drawing. This is the actual. So this has got to be the drawing, and this is going to be the actual. Okay. So let's do the length first. So the 40 feet is the actual distance. So because that's the actual distance, we're going to put that on the bottom. Okay. Because again, on the left side we've got the drawing distance on top, and then the actual distance on the bottom. So we got to do the same thing over here. And then obviously to get from 4 to 40, we're going to multiply by 10. So 1 times 10 is obviously 10. So x is 10, or the length of the drawing would be 10 inches. So now let's do the width. So same thing, 1 inch, 4 feet. This is the drawing. This is the actual length. Okay. Over here we got our drawing length, our actual length. We're looking for the drawing length. All right. Our actual width, our actual width is 25 feet. So we're going to put that on the bottom here, right? Because again, in this case, we've got drawing on top and actual on the bottom. So a little harder to get from 4 to 25. So let's do those cross products where we've got 1 times 25 is 25, okay? And then x times 4 is 4x. And then we're going to solve by isolating this variable. We'll divide by 4. All right, we've isolated our variable. We divided by 4 on this side. We have to divide by 4 on this side. So we're going to take 25 and divide that by 4. 4 goes into 25 6 times. That's 24. 5 minus 4 is 1. We're going to take that remainder and we'll put that over our divisor. So x is equal to 6 1/4, which means that the drawing is going to be 6 1/4 inches wide. All right. And then if we were to draw this, right, we'd take our ruler, right, and you know the length would be, a shout out to the fire department here. The length of our drawing would be 10 inches, and then the width of our drawing would be 6 1/4 inches. So it takes a little bit of practice, but that's how you do it. And I hope that helps. And I'll talk to you guys soon. Be well.